So till then you can discuss with us if you would like to know more about the things. Arul and Samanya, we are waiting for other people to join. So please wait for 5 minutes. Let us join for others. We will conclude this webinar in within 40 minutes, right? Welcome to all those are joined over here. Please wait for a few minutes. We are about to start. So we are just waiting for a few more candidates to join. So dear all, dear all, we are going to start the today's webinar. So good evening all. We are starting the session regarding the career opportunities in nuclear science and technology. First of all, I would like to invite my senior colleague. She is assistant professor here. She will welcome you on behalf of our director, Professor Alpna Goyal. So, Ashna madam, kindly join us and welcome to our students or tell something about the institution so that they can aware about all these things.
Good evening to one and all present here. I hope I'm audible. On behalf of Director and Head, Amity Institute of Nuclear Science and Technology, I welcome all the students and their parents who have joined us for this webinar on career opportunities in nuclear science and technology. Just to give a brief about our institute, I would like to mention here that we are Amity Institute of Nuclear Science and Technology. Under the aegis of Amity University, Uttar Pradesh, we are based in Sector 125, Noida, in the Delhi NCR region. And just give me a moment, I will share my screen. So this gives us the details of our website that you can visit to get more details about our programs that we are offering, what our alumni are doing, what are our events and activities that we have conducted, and any updates about the future events that we would be conducting. So basically, we are offering BTech, MTech, integrated degrees in nuclear science and technology, BSc and MSc degrees in radiation technology. And with BSc, we have an option to upgrade from the conventional BSc programs to the honors or research degrees that goes on for 4 years. Apart from that, we are also offering PhD degrees, both full-time and part-time in the area of nuclear science and technology. As you can see through the slide, that we have the most advanced state-of-the-art laboratories which have been placed here to make sure that students get hands-on with radiation detectors, calibration of these detectors, get to know about how to handle radioactivity, and get a good hands-on in terms of the detectors, the most advanced detectors that are present for detection of radiation. This also gives you details about our prominent employers. So our students have been working in both government and non-government agencies in Delhi and across India. Students also enroll for higher studies and they opt for MS programs. And there are some of the fellowships which are mentioned below, which they can opt for. The IAEA Marie Curie Fellowship, which is mentioned below, is also applicable for students to take up master's program in our institute, wherein they will be given full tuition fees from the IAEA, that is the International Atomic Energy Agency. But these fundings are only available for girl students. So whosoever wishes to join our MTech program in the nuclear science and technology may please enroll, can try putting their candidature to IAEA for pursuing the master's program at our institute, and they would get a very good scholarship amount to pursue this entire program, and it will be literally free of cost for them. But of course, the number of scholarships are limited. So it will be based on their candidature, their profile, and the best letters, the statement of purpose that they are going to write. We are there in case of any help that is required from our end. So you can contact us. Our phone numbers are mentioned on the website. The website has been mentioned here. Should you wish to get in touch with us, you may please contact us through the mail IDs mentioned on the website. Even our phone numbers are mentioned. I would be happy to take up any queries in this regard, but I would not stand in between the program. So I quickly hand over the stage to the next speaker, and she would be telling you about the applications of radiation technology. And I'm sure this would be a very interesting session for you all. So I look forward to the next session. Any queries, questions can be put up in the chat box because you don't have an option to unmute yourself. So please feel free to write any queries in the chat box and we would respond to it. Thank you so much. I hand over to Dr. Arpita.
So, am I audible to all of you? So first I'm just discussing about the atom. Two picture of the atom I am showing here. One is a stable atom and another is unstable. In atom, you know that it is a composed of nucleus and an electron. Nucleus is containing neutron, proton, and which is surrounded by an electron. In case of stable atom, you can see that neutron to proton ratio is 1. So they have equal number. Whereas in case of unstable atom, neutron to proton number could be greater than 1 or could be less than 1. So that to attain a stability, it has to emit something so that can be stability can be attained. And here you can see I've also represented with this plot neutron to proton number. In this straight line, it is representing neutron to proton number same, whereas the deviation you can see by other part, which we can consider as a unstable nuclide. So because of this instability, the radioactivity will be coming to the picture. So I thought I should tell you what is the radioactivity, which is nothing but the process by which nucleus of an unstable atom loses its energy by emitting ionizing radiation. So now you may be curious to know that who discovered the radioactivity. Here some pictures I'm showing starting from this picture. It's William Longin who discovered X-rays, and then Henry who discovered radioactivity. In the middle picture is the Marie Curie and Pierre Curie. Marie Curie coined the term radioactivity because she discovered radium and she separated radium and polonium from uranium ore. And here is the picture of Geiger, who is the inventor of simplest detector, which we call as the Geiger-Müller counter, and then the Enrico Fermi. He is the inventor of fast nuclear reactor in the world. So let's see what is radiation. So radiation is nothing but it's the emission or transmission of energy in the form of wave or particles through phase through different material medium. In this slide, I have shown an electromagnetic radiation spectrum. You know that there are two types of the radiation. One radiation is called as a non-ionizing radiation. Another radiation is called as a ionizing. Basically, nuclear radiation or ionizing radiation. So as you can see, this left-hand side here, I'm just showing as a gamma rays, X-rays. They are falling under ionizing radiation. And most common type beta, gamma, and neutrons. Alpha is nothing but it's a helium nucleus which is having 2 is an atomic number and 4 is a mass number. Then a beta is nothing but an electron. Gamma is the electromagnetic radiation, and neutron is a neutral particle which is having a mass of 1. But this picture very clearly represent their property. So as you can see, alpha is a helium. It's having little bit heavier, so it cannot move very fast. Penetration power is very low as it can be stopped by paper. Whereas beta penetration power is little bit higher than alpha, so that you need some material to stop it. Basically, a thin aluminum sheet could be useful for stopping this beta. And as gamma and X-rays are the electromagnetic radiation, you need material which is having high density like lead could be useful for the stopping it. And for neutron, we can use water or concrete, the medium. So in this slide, I have shown about different isotopes. I have already mentioned that isotope could be two types. One is a stable, another is unstable. Unstable isotope is nothing but radioactive isotope. And here I have given some example. A simplest example is a carbon. You know, in nature, carbon is having three isotopes: carbon 12, carbon 13, and carbon 14. In these three isotopes, 12 and 13 is a stable one, and 14 is an unstable. So it's a radioactive in nature. And here I have classified different isotopes, radioisotope based on their emitting radiation. So these are gamma emitting radioisotope, beta emitting, alpha, and neutrons. And I have given some examples. Gamma emitting radionuclides are nothing but those isotopes which can emit gamma, and examples are 137 cesium, cobalt 60, and there are many more. And beta emitting radioisotopes are the isotope which can emit beta. So examples are 90 strontium, thallium, there are many more. Similarly, for alpha and neutron also I have shown example, because the radiation emitted from this isotope is having very, very important application, which I'm going to discuss in my other slides. So basically, there are two applications of radiation or nuclear technology. One is a power application, another is a non-power application. So let me start with the power application. So as we all are familiar with the one of the problem that we call as a climate change due to global warming, and that is actually increasing day by day. So our requirement is the net zero greenhouse emission, and nuclear energy could be one of the very good alternative source of electricity production, which can reduce carbon emission to a almost zero level. And in world and India, we have many reactors which can be used as a tool for the production of this nuclear energy. There are two processes by which nuclear energy normally produced. One is called as a nuclear fission, another is a nuclear fusion. In nuclear fission, heavy nuclides are break into smaller one if it is bombarded by neutron, where heavy amount of the energy will be emitted. And other case, in the fission, there are smaller nuclei can be joined together and can produce heavier nucleus, but in this process also of energy will be produced. So I have just taken one example, and I just thought to tell you how intense will be the nuclear energy. So here example, you can see that if I take 1 gram of 235 of uranium, and if I and this isotope of the uranium is called fission, it can emit energy almost 1 megawatt per day. And to obtain this amount of energy, you need 3 tons of coal and 2,300 liters of petrol. So from this example, maybe it will be clear to you that how important nuclear energy is for today's life. And so far, we have 22 reactors with total capacity of 6,780 megawatt in operation, and we'll reach this capacity to 22,480 by 2031. So let's move to the non-power application. There are many applications are there in our day-to-day life. Maybe nowadays we cannot think our life without radiation technology. So I'm starting from the food preservation. As you know, due to weather condition or insect pest, there are a lot of wastage of the food products. It is the, if I just roughly estimate, it's almost 25%. So we can use radiation technology for the increasing of the shelf life of the products. For an example, different spices we can keep for a longer time if you are just irradiating it with the help of different radiations, specifically to the gamma radiation here. Not only that, there are some type of the food products which can ripe very fast, and there are some food products they have a sprout formation. If we can just delay the ripening process and also inhibit the sprouting process, we may keep them for a very longer time. And so radiation technology is also useful for sprout inhibition and also for delay the physiological process, which we call as a ripening process. And you all are familiar that X-rays are used in baggage scanning in the airport and other places, which is also another application of radiation technology. And also radiation technology is very important for sterilization of the medical equipments like stretcher, blades, which will be used for surgical purposes. Then another application is the desalination of the water. Though we have one part of life, but we have seen that there are a lot of amount of the water. We should remove the salt content, and radiation technology is very, very important for desalination of the water. As you know that Indian economy is agroeconomy, and a lot of people are just surviving on this field. And our GDP, if we see, agriculture is also contributing a lot. So radiation technology could be one of the very, very important tool for agriculture purpose for increasing the product amount and also to the quality. Because we have seen due to heavy rain, sometimes in the less rain, there are a lot of wastage of the production. Not only that, even the product quality will not be that good. So that case, radiation technology will be very, very helpful. So in this case, basically, there is a term called mutation is helping to increase the or to maintain the quality and quantity of the food products. Another application is the space science. So basically, you know that there is a method we need it for rocket launching is the propulsion. So here maybe a nuclear battery in the form of RTG can be very, very useful or alternate source for nuclear space technology. Another very important application, which I'm going to discuss in my next slide, that is the medical application. Nowadays, without radiation technology, maybe we feel that the treatment part or maybe diagnostic part would be incomplete. There are two models. In diagnostic, we can know what type of the disease people is having, and there are different kind of the technology, single photon emission tomography, MRI. Though MRI is not purely nuclear, but MRI also use it. Then X-ray. All you are familiar with maybe X-ray, because if we have to know any structural information because of the fracture or anything, so you can go for X-ray. And for treatment, we can use different radiotherapy technique. So 3 techniques I have mentioned here. One is called brachytherapy, another is teletherapy, and last one is a gamma knife. So based on the requirement of the treatment, people can use any of these. Brachytherapy basically use where you need to place the radioactive source very close to the point where the cancer is there, and teletherapy source can be used from little bit a distance, and gamma knife is basically used for if any problem or malfunction or tumor is present in the brain. There are also some, and very, very small amount can be used for different application. One application is the leak detection, and this application is very, very important, will be very, very huge, where it is very difficult in the normal way to know what is the leak, where the leak happened, and this leak could cost a lot of wastage of the product, and maybe company. Another clear, and for that the sand to be removed, and it has to be dumped in some other place towards and can block the sitting chance. So that can cause a problem in harbor. So here also radioisotope is very, very important. Here I'm just discussing about the application in environment, specifically for sewage sludge hygienization. Sewage sludge is nothing but the domestic waste what is collected. It is having solid part, it is having liquid part, and along with that, it is having a lot of bacteria which can cause different disease. But if we are able to remove this bacteria from this sewage, then solid part can be used as a manure. And here, radiation technology is very, very playing very, very important role. And India, we have one irradiation facility where sewage sludge can also be irradiated. Smoke detector is also another form of application of radioisotope, where alpha source 241 is used, and here you can see I have represented pictorially. So this all application of radiation.
So thank you, Dr. Arpita, to share about the applications of the nuclear isotope or nuclear energy and other things too. If you are having any query, you can write in the chat box regarding this. Now, I would like to invite Dr. Alpna Goyal, who is the HOI of the institution. So I would like to invite ma'am, please open your mic so that you can address the gathering over here.
Thank you, Dr. Unnati Gupta.
Thank you.
And this is my privilege to welcome you for this career counseling program arranged by Amity Institute of Nuclear Science and Technology, Amity University, Noida campus. I would like to welcome you, each one of you, and thank you for joining for this session. And I think my faculty and we would be able to give you some glimpses of our institution and also about some knowledge about this new challenging area, that is nuclear science and technology. This is very challenging field, but at the same time, number of opportunities are available in this area. And as you are aware, in a present scenario, that nuclear is one of the most important area where you can pursue your career. And I'm sure you will get good opportunity in the future, because slowly the government of India, as you all are aware that the nuclear program is with our government. So government of India soon they will be going to create a new job, new paradigm for this field. So you will be the lucky fellow who will get the good opportunity to work in this area. So I welcome you, each one of you, kindly visit to this facility and get the how we are catering the student and giving the knowledge of about this subject. This subject, I'm sure once you will visit the facility, you will enjoy and you will also learn that how important this subject is, and the center of excellence which we have established for the student. They can do their project, their research, they can study, they can do their experimental work in the world-class laboratory. I am sure this type of a laboratory you will not find anywhere in any IITs even. And although this area is very challenging, and presently the scenario is not very good, there are only few private industries who are taking the student, but I'm sure future is in the nuclear. As you are daily, you are hearing the news that nuclear will be, India mission is to become a developed country. And if India want to become a developed country, India has to take a good nuclear program. So lot of new reactors are going to commission soon in India. And we will be changing the total paradigm of the India, where we will be working in the nuclear area. As Dr. Arpita Datta told you, there are not only power production, but lot of applications are there. So not only in nuclear power production field you can work in number of the areas, number of opportunities are available in the hospital, in the agriculture field, in the food, in the healthcare, and also in many other area. Even you can go for the higher studies. I think if you are passionate for this subject, you can see that lot of student of this department is working internationally. So there are fellowships, that is Marie Curie Fellowship, Erasmus Mundus Fellowship, Sarna Fellowship for the nuclear science student. And I would like to share, and I want to motivate the girls student, because the Marie Curie Fellowship is especially announced for the female candidate in this area. So please join this program and get a good exposure. This is very different discipline, and you will be unique engineer. That only I can say, I can assure. And the faculty here, they are all from the good place, PhD from IITs, from good universities. And as I can share, I am PhD from IIT Roorkee. So similarly, you can see for other faculty also, and you will be meeting other faculty during the interaction if you visit to the department. So I welcome each one of you. Kindly visit whenever you want to visit. Let us know, so that we will give you the, we will show you the our facility and our institution profile we can show. Even you can go our website. We have uploaded the activity and the placement where our students are working. So I think my faculty or Dr. Unnati Gupta, definitely she will be sharing you the website link. So you can go and see the website and you can explore the opportunities as well as career prospects where you can apply. So welcome you all once again, and over to you, Dr. Unnati.
Thank you, ma'am, Dr. Goyal, to give the glimpses about the institutions and motivate to the student. Those are listening to us. So, if you are having any query to the HY madam, you can write to the chat box. Dear participants, if you are having any query, you can write to the chat box. So no query in. So we are proceeding the next session of the present today's webinar. So I would like to invite Ms. Archana Yadav. She will give you about the glimpses of the remote facility over here, which is the unique feature. And she is assistant professor here, so we'll give you more details about that. So please, ma'am.
I hope I'm audible. Thank you so much, Dr. Gupta. So the session is devoted to giving information about our laboratories, because that is what is the main crux of the institute, that we offer hands-on training or hands-on experience with regards to radiation detection, detector calibration, shielding studies, and all those things. So I would like to give a brief about our existing equipment that we have in the laboratory, and then I will share with you the functionality of our remotely accessible laboratory. So these pictures are actually handheld radioisotope identification devices which are available with us. And these are compact devices which can be carried even in the field to detect radiation. And you can see in some of them that there are some readings which are coming which tell you about what is the ambient radiation that is present in the environment in that area. So this is used by the first responders to detect radioactivity in case there is a spillage or there is an accident while the radioactive material is being transported. So our disaster response agencies, the first responders that can be health physicists, everyone will use these kind of equipments to know what is the level of radiation nearby, and they will help us, help the general public prevent going to a level radiation field that is higher, and also will protect themselves. So this doesn't say that we need to fear from radiation. With proper shielding, with proper precautions, safety measures, we can maintain our safety. Almost all of the panelists that have joined here have been working in this field for past 10-15 years and even more. And they are healthy, they are doing well, and they are living a very normal life, because they are employing all safety measures to protect and prevent any undue exposure to radiation. So these are some of the handheld detectors that you can see, and they are of different sizes to ensure that they have different efficiencies of detection. But they all can be handled very easily without any active power supplies, by batteries, by rechargeable batteries, or the inbuilt batteries that they have. This is the remote laboratory that I was talking about. So all the radiation detectors that are required to detect all kind of radiations that were mentioned by Dr. Datta, alpha, beta, gamma, everything can be measured with the help of this remotely accessible laboratory. It has detection capabilities of characterizing various detectors, from scintillation detectors to high purity germanium detectors, and also GM counters. Apart from that, it also gives us the flexibility of characterizing alpha sources. So we can see, if my pointer is seen, this setup, which is kept at the back, this is basically an alpha analyst that detects alpha particles. There are chambers which are there in front. They will detect, we will place a source over there, and all the data can be taken on to this screens or systems which is shown here, and you can access this system sitting at your home. So in case, God forbid, if we again face a problem like COVID and we have to conduct our labs from our homes, no student will be deprived of handling detectors. We have ensured such facilities are available at our institute. Here we can see the Geiger-Müller counter, which is the very fundamental detector that we use to detect radiation. This is a portable type high purity germanium detectors, the best of the detectors that you can get for characterizing, for getting signatures of different materials. And it's very efficient in terms of getting the very minute traces of material that is present here. The other setup that you can see here is where we can characterize different sources. So these yellow colored are the sources. Different sources we will place here, and you will have flexibility to move them. I will just show you with the help of the actual demonstration of the lab. We can move this arrangement to ensure different sources come in front of these detectors, and we can characterize detectors which are kept here and also get signatures of these sources. These are different shields which are connected here. So we can assess which kind of material would be the best to shield a particular type of radiation source which is kept at the center. This will be done on request basis. So you will place request that I want a certain kind of source to be placed here, and you can rotate again this table with the help of the lab view arrangement that we have provided to change the shield that comes in front of the detector and see how it is, how effectively it is shielding. This is an inverse square law arrangement which is fitted here. So there is a fundamental law that as you move away from the source of radiation, the radioactivity decays down, just like fire, just like sound, just like light. Similar kind of behavior is observed with radioactivity as well. So to take up that experiment, this inverse square law arrangement can be utilized. And this is where we place our detectors. These are fixed detector stations that have been set up. So you can see here high purity germanium detectors which have been fixed here. And this is the data acquisition system. Also on the top here, you can see an alpha detector system that is placed here. So we can perform different kind of experiments with this setup available, but this is a fixed setup. What I showed earlier was a remotely accessible laboratory. So every kind of detector that you can see here has been replicated onto the remote setup, and we can do all the experiments sitting at our home on the real data. It is not that you're getting any simulated data or any other data. All real-time experiments can be done sitting at the comfort of your home in case you're not able to come to the institute for taking up the laboratory sessions. But for a regular student to come onto the campus, it is essential, and you must have a minimum attendance to qualify to sit in the examination. This is just for an emergency, exigency, and to cater to a COVID-like situation. This slide tells you about the neutron detection, neutron detectors that we have procured. So this is a liquid scintillation based neutron detector that is kept here. And this is the signal processing and data acquisition system. Also, we have neutron survey meter. So you can see a ball-like structure which is kept here. That's a neutron survey meter because neutrons are highly penetrative. So you require a larger volume for them to be detected. Also, below towards the bottom side, you can see an area monitor or an area survey meter, which will be kept in the facility to monitor the ambient doses in the environment. This is our computation laboratory where students can sit and do work on different kind of software that have been present here. And also we provide them with very specialized simulation softwares, which they have to work during the course of their study at the institute. So this includes all alpha, beta, gamma, and neutron detectors that we have in our labs. But of course, the neutron detectors are not going online as of now, but we will make all measures to make sure that they also go online with the help of the remote lab. But as of now, this system is only available offline. So that would be all about the labs that I wanted to share. If you have any questions, you can let me know. Or we can move forward with the demonstration of the remote lab that we have in our facility. Okay, so we have a message from Adyan Singh. Adyan, would you mind waiting for some time? Because the people who have joined on time would be eager to leave. So please, if you can wait for some time, we will give a recapitulation of the entire session once we are done with our agenda items. Would that be fine?
Yes, ma'am, you can.
Okay, right. So Akashdeep, to please share the screen and show the setup of remote lab. Akashdeep, I hope I am audible to you. Please share the screen. Please reduce this view to get a view of the camera first. Give a full screen view of the camera. Please change the camera once. I need to get the view of the other camera. Full screen for this. Make it full screen. So we will give access of this system to you through an AnyDesk software. And see, you can see the same system that was shown onto the slide. We have 5 different sources which can be kept here. You can rotate this entire rotary table with the help of the LabVIEW software, which was just shown. We'll get back to that. And we have this table, which you can see here. The source is kept on the white portion, if you can see the white portion. I request Akashdeep to kindly show with their hands because they are there in the lab. So there is source folder. And this is the LabVIEW software, which they are going to log in and try to move that without any personal interruption. You can move this entire arrangement. You can make sure whichever source we want comes in front of the detector. So as of now, the detector is not placed, but the empty spot that you can, the lead shield that you can see will be where the detector will be placed. And see, it is slowly moving from one source to the other. Once we press give the right commands. There are specific angles indicated below to make sure that every time once you give the next command, it will go and stop at the respective position. So we can slowly and steadily take reading for all the radiation sources that are listed here. Because you don't know, I'm giving you some brief that these are all standard calibration sources which are used in the industry. So by standard calibration, we means these are like the standard benchmark that are given to us. They will tell you about the detector configuration. Once you assign these configurations to the detector, they will be able to get the signatures of any source that you provide because they have inbuilt libraries with them. So they can search for the specific gamma signatures and tell you which source is present in this location. So if you're going to the field with any of the handheld detectors or any of the tabletop detectors, once you get any radioactive source in front of them, they will be able to identify which source is present on the basis of their energy signatures. Those are their characteristic energy signatures. Likewise, Akashdeep, please stop this rotary part and show them the inverse square law. So again, the fundamental inverse square law of variation of radioactivity, that as you go away from the source, the intensity drops down. That can be done with the help of the linear table that is seen on towards the right of this setup. And here you can see the face of the GM detector, the 0 count that you are looking at here. That is telling you that there is no count as of now present, but if we start the counter, it is going to give you counts depending upon which source is kept here on the source folder. As of now, the source is not loaded here because there are students which are sitting in the proximity. We don't want any undue exposure to any of the students. And you can see this, the source folder that is moving. And the silver portion that you can see here is the detector. That's the GM probe. This source can move away from this GM probe and we can take readings through the rate meter software that is again provided in the system itself. So that will give you a log of the readings that are done. And that is how you can do the very fundamental experiments, shielding characterization, inverse square law variation, detector characterization with regards to different kind of detectors. So that is all from my side. I would be happy to take up any queries or. Thank you, and I hand over. Thank you, and to Dr. Sudatta for the next session. Thank you.
Dear students, if for any query, you can write in the chat box or you can directly ask. The next section, if there is no query, then I would like to invite Dr. Sudatta. She will give you about the glimpses of career and future prospects in nuclear science and technology. Please open your mic. Camera, please. Sudatta ma'am.
Hello, students. Yes. Hello, students. So I think you came to know about all the things, whatever nuclear industry is about. So we have given you glimpses of our detectors, our whatever things we have here. High kind of like there are a lot of amenities here with which you can do research. You can go learn about it. You can learn about it. So here, now coming to the prospects, what kind of job do you get and what are the options you have after studying? So the options here, career options is very important because that is what we look for. So here, what do we do? So in career prospects, like we study about nuclear reactors also. So nuclear reactors, it is totally government aided. Like in Department of Atomic Energy, we deal with nuclear reactors. So the career opportunity is at nuclear power like design, construction, operation, maintenance, all these nuclear power have medical health physicist, nuclear weapon health physicist, all these health physicists are there, and we are also, one of our students got job as an RSO also after studying RSO opportunity, radiation safety officer, radiation safety operator kind of opportunity here. Then R&D for backend of nuclear fuel cycle reactor safety and reliability is also there. Then careers in nuclear medicine is also there. Careers in food processing is also there. Careers in nuclear space and technology is also there. And international safeguards, including nuclear security, is also there. Now here we deal with detectors also. Now this detector facility is also opening at our end. Some of the companies who deal with nuclear detectors are also recruiting our students. So this is, since nuclear engineer is highly specialized job, we have high academic qualification and you can expect a good salary there. Now, scope of advancement is also very good in this. Like the students who have gone for BRC Mumbai in radiochemistry division, safety and security study, isotope and radiation. So these students are doing very well. 6 of our students has been recruited by BARC. They have gone through OCS program and are scientific officers now. Like whatever has been mentioned in the in the left panel, they have done everything. They are there, and the potential recruiters this is from government. And another thing is TFR Mumbai, people have done their internship Students have done their internship from TFR Mumbai, IUSC Delhi, NAPS Narora, Jamia Millia Islamia, Delhi University, IIT Ropers, to name a few, SDS Life Sciences, NIAS Bangalore, University of Shashkaten. So these are to name a few. Like there are certain institutions or companies who are looking for trained nuclear engineers or technologists and scientists included. So like this, in Department of Atomic Energy, Nuclear Power Corporation of India Limited, Board of Radiation and Isotope Technology, DRC, IGCAR, VCC, SINP, then SDS Life Sciences Private Limited, Manesar, Larsen and Toubro, Nuvia India, New Delhi, Atkins, and Advanced Tech is also there, which is located at Mumbai. And internationally, our students have been recruited as an postdoc fellows as well as doctorate fellows in University of Paris, then Tsinghua University, Taiwan, IAEA, Vienna, Texas A&M, GSI, and they have done Erasmus Mundus Fellowship, then CERN, then International Thermonuclear Experimental Reactor, ITER, France, Orano, France, GE Hitachi, World Institute of Nuclear Security. Also, they have been recruited by them. Washington, then Atmostroy Export, Russia. So here about the achievers, I have named a few of the achievers.
Sorry,
certain batches.
sorry,
Like Erasmus
Ray,
Mundus Fellowship.
Dr. Ray.
It is a three-continent
Sorry, Dr.
program.
Ray, to
name,
interrupt you.
Explain it comprises
Hello.
of Spain, Italy, and France.
Hello.
In this program, you can
Hello.
opt for masters, and after that you can do PhD from some
Hello,
other
can you hear me, Dr. Ray?
fellowship also. Likewise, BRC has got DGFS doctoral fellow. So these are the few of the fellows who are working there and has worked there. Then, okay, in between, I think I hand over the mic to Professor Goel. She wants to add on something.
Yes.
So please, ma'am.
Yes, Sudatta, you have not mentioned. Can you go to the previous slide?
Ma'am, Alpna ma'am, please open your mic, please.
I am in there in the mic. क्या हो गया मेरा mic? Can you not hear me?
Speaker on. Volume on करती हूँ.
Thank you, ma'am. Thank you, ma'am.
Like these are the students, scientific officers. Some of the students have been recruited by OCS program, scientific officers. Then Atkins Bangalore has also recruited some of our students. Like these are the students, these are the 3 students from the batches are also written there. Then Diksha Gupta, Dr. Diksha Gupta, she is a doctoral researcher at Areva, Germany, and presently she is doing an Accenture. So these are freshly recruited, I mean, our new achievers of 2023. Like these are the name of the students who have done in IAEA Marie Curie Fellowship, got. Then Rita Sara is a DDFS fellowship. So these are some of the students. We have put their photographs also. We are very proud of them. Advanced Tech Controls is also taking some of our students. The new recruit from our batch is Tushar Gupta. So these are the students who are in DAE institutes who has been recruited, but we have to, they have done the work very rigorously. They were hardworking. So the students have to be very hardworking to match the eligibility criteria of for placement in government organizations. And there are certain private organizations like SDS Life Sciences, Larsen and Toubro, Nuvia, Atkins, and Advanced Tech, who also recruit our students. They give the students a very good package. So, and increasing training opportunities for students in various research laboratories in India as well as abroad. Large number of students selection in various summer training program, increasing placement opportunities at BRC and other private organizations. So we are also working on this. So this is about us, our whatever whatever students have got career opportunities for students who are studying this. So if you have any question, you can write in the chat box. Now over to Dr. Unnati Gupta, because I think she will recapitulate whatever has been said and answer the queries of the students.
Thank you, Dr. Ray. To give the glimpses about the career prospects in nuclear science and technology. If you are having any query, so kindly let us know, or you can write in the chat box, or for the more details, you can explore our website. We are also going to share a link of the video. You can see our facility via video. If you would like to come personally, as our HOI ma'am already requested to all of you, you can come, you can write us, you can come anytime. For the coming, you can write us first, so we can make a provision for your visits. So if there is no query, then on behalf of institution, I would like to thanks to the Honorable Founder President Sir, Dr. Ashok K. Chauhan, Honorable Chancellor Sir, Dr. Atul K. Chauhan, and I would like to thanks to the respected Vice Chancellor Madam, Dr. Balvinder Shukla Ma'am, to provide this platform. And I also would like to thank to the IT team for providing this link and connected with us during this session to resolve the queries. So thank you. At last, I would like to thank all my so I would like to thanks to all participants to join us. And I would like to request to the Archana Madam, kindly recapitulate the things for those late joinees.
Thank you, Unnati ma'am. I thank all the attendees once again, and I'm happy to take up any queries that you might have. Adhyan, in specific, how far have you missed? We are not sure, so please let us know. What would you like to know more about us? Arvind sir, if you may please upgrade the attendees that are present at this moment, so that they can unmute and they can ask any queries if they have, please. No, all are upgraded now. They are coming here. Then now you can unmute yourself. You can also switch on your camera if that's visible. All of you now have all the rights, so you can unmute yourself and ask any of your questions to any of our panelists. All are present here. I request all to switch on their cameras.
Ma'am, can you repeat the first half an hour part in an overview? I was not able to join, so if you could give an overview, it would be better for me.
Overview about the institute.
Yes, ma'am.
Okay. Just give me a second. I will share the page with you.
I would like to ask from where you are, which place from Delhi?
Ma'am, I'm from Sector 46, Gurugram, Amity.
So you are from Gurgaon. So
Yes.
I would like to suggest if you can visit to us so that we will show you the facility. You can meet the faculty.
Ma'am,
In
where is
person.
the center for that?
Yeah.
Where is the center for that?
Yes, we will share you the address. It is in sector 125, Noida.
Okay.
Okay. Miss Archana, please write a address, full address of Amity University in the chat box.
Okay, ma'am. Okay.
So
Again,
you
we are
can-
very nearby. We are in Delhi NCR only, and we have the magenta line that connects you, and you can drop from. You can take magenta line and deboard at Okla Bird Sanctuary. From there, Amity is just 1.5 kilometers away.
So, ma'am, do I have to take some appointment or something, or just come at the school or the center and just visit it?
There are regular sessions which are conducted for faculty for parents and students both. So you can join for those sessions, or you can write to us and come any day. You must inform us beforehand so that we'll give the information on gate, and there will be no problems for you to enter. Any day you are most welcome. That will not be a problem.
Okay, ma'am. Thank you.
And you can visit our website. I'll give the link here as well. You can visit our website for all the updated information. I'll just give you a glimpse of the programs that we have. Just give me a second. Address is given. Nearest metro station is Okla Bird Sanctuary on the Magenta line, and you can also take the blue line and deboard at Botanical Garden. From there also you will get autos and cabs are available.
So I have to if I want to come at the center, I can contact on this number.
Yes, please. Yes, you can. You can.
Okay. Thank you, ma'am.
Just give me a second. I'll share. Okay, so I will give you a glimpses of our programs as well. You are connected, right? I hope the slide is visible. Right? These are the programs that we offer. BTech, MTech, and BTech plus MTech integrated 5 years course that is in nuclear science and technology. Apart from that, BSc and MSc programs in radiation technology. And with the BSc program, you have the option to upgrade to get the honors degree. That course will now run for 4 years. Otherwise, it is conventionally a 3-year program. We also offer PhD programs. It's full-time and part-time in nuclear science and technology. The pictures that are depicted here are glimpses of our laboratories, both on the remotely accessible and the static laboratories. that we have. The prominent employers that you can see here are both national and international agencies who are working in the sector of nuclear sciences and applications. So we have, our students are going to both the government and the private sector, ranging from research institutions to pharmaceutical labs and startups. And some of our students have also been to Ariba for their PhD programs and now are working with Accenture as Dr. Ray just mentioned. There is an option of getting international fellowships, and many of our students have been recipients of these very esteemed fellowships. Some of them are very specific to applications in the nuclear sector, and some are general fellowships that are provided to nuclear physics aspirants. So that's Erasmus Mundus, the Lisa Meitner programs, Marie Curie fellowships. And apart from that, even the Serena Erasmus fellowship is available. That is for the applications in the applications of nuclear in various sectors. Apart from that, there are many universities in Europe, in US that are also offering master's fellowship and programs, and all of our students who wish to apply are getting through successfully at places of repute. And the list of all the students where they have joined was already shared with you. If there are any other queries, I can take them up. Thank you. Okay, we have one query from DRSS this. I can't see. Acha, DRSS, girl. Arvindji, please upgrade the rest two attendees also. Dear students and or parents, whosoever has joined, you can speak about your queries or you can write in the chat box. Commerce student. Dear, we are an institution which is in the science and engineering and technology side and giving some courses in the science background, but we cannot give courses to the commerce student. Any other queries? Yes, this session is only for science students. Any other questions or queries? Okay, but the respective department might hold some sessions for the commerce students as well. We are not aware of it. I'm sorry. You can contact the helpline to get the phone numbers of the respective department. And they will let you know better. Any other queries? So thank you everyone for joining. If there are no more queries, probably we can close for the day. Thank you so much, Arvind sir. I think we can close. Dear students, you have all the details. You can write to us, you can call us, and you can get in touch with us. In case you have any concerns, you can also come and see the facility. Thank you. Arun sir, we can close now. Thank you. Thank you, everyone. Have a great evening. Take care.
ये चढ़ा अरविंद सर काइंडली सेशन सभी के लिए बंद कर दीजिए।
अच्छा ठीक ठीक है।
Ma'am, shall I close the session? Unnati ma'am, shall I close?